Okay, so we're already on?
Yeah.
Okay.
So now I have to go clean up script.
All right, we'll wait till Simon or Igor makes it, just so that we know everybody's here. The question you're going to get in every single session is, how many of you are new users? One. Okay. How many of you are advanced users? Alex, raise your hand.
What does that mean?
Well, this is self-selection. Do you think you're an advanced user? So about 5, 6 advanced users? 6, 7, okay, all right. And everybody else is in the middle, or did I miss a category?
Troublemakers.
All right, come on, Igor. We're gonna go with that. So my name is Noel Gorlick. I'm one of the founders of Earth Engine and the guy that answers all the debugging questions. Last year, I answered about 2,000 user emails on the forum, which if you do the math, works out to about 8 a day. And they take as much as an hour a piece. And so if I was rude to you, that means I got to you late in the day, and I apologize. Yeah, that's a lot of, I spend a lot of time helping our users get over their problems, or the problems we caused them. So what I'm hoping that this session teaches you is, one, about our new feature, but then also some tips and tricks on how to debug your scripts in our weird, wacky environment. Point you at some common errors that if you haven't already encountered, you certainly will sooner or later, and then what to do when you encounter them. And then a little bit of advice for how to get help. If you self-identified as anything other than a brand new user, you've probably already tried to get help once or twice. I hope it went well. But as you are perhaps aware, there are ways to make that faster, more efficient, and more likely for us to be able to get you an answer. So. All right, so we launched a brand new feature called profiling this week. Yesterday? Yeah, we'll go with yesterday. To get it, you pull down the gear icon, and there's a turn on profiling option. When you do this, everything that you then send to the server gets profiled, and stuff comes back. There's a profile tab where all the information about the profiler comes out, and it looks a bit like this. Before we talk about what's in that, it's important to note that when you turn on profiling, you are disabling caching, which means all the good parts of using Earth Engine go away, right? Your scripts get slow. They're gonna even more likely to run out of memory. So we turn off profiling so we can actually measure how long things take, because if you got something out of this cache, then we don't know how long it took. And your entire crazy long script might run in a few seconds, and we got no answers, and profiling didn't help. So we have to turn off caching, actually run it with real for everything new, and this can make it very slow. And in fact, scripts that ran without the profiler might not run with the profiler enabled, but hopefully you get enough information to be able to tell you something useful about your script in the process. So when it runs, it looks something like this. This is the tab. You get 3 columns that give you some information about some numerical information about what's going on, and then a description about the algorithm that was being run. So in this particular example, I have sorted based on memory usage, and the most memory usage item in this thing appears to be the image.clamp algorithm. This is how much compute time it took, this is how much memory it took, and this is how many times it was called. None of that is actually true. Those are just rough approximations of amount of memory, how much time it took, and count. They really mean different things, and in a parallel distributed environment, often we're not actually quite sure what they mean, Kevin's probably sure what they mean because he wrote it. But other than
Yes,
him,
but that doesn't mean that they're helpful for you to figure out. This is just, these are the best numbers I could figure out to give you.
right? So it's the back end is weird. There's just no way around it. We try to extract what information we can out of the signals that we can and present them to you in a way. And the best things we could tell you is this is how much compute it took. This is how much memory it took, give or take. And this is how many times it ran.
Sorry. Compute column per call or just aggregate?
It is aggregate because it doesn't. The question doesn't make sense in our environment.
You didn't divide it by 6,000.
No.
Yes. If you want the individual numbers, you will have to divide by the count yourself. But that doesn't necessarily make sense. But you can do that. Like if you change something in your script and the count doubles, then dividing by half, you should find you have the same numbers before. But like I said, it's tricky because it's parallel.
Every part of this is an approximation, and the entire thing may or may not be useful to you. But we fought long and hard about is it more valuable to show you something than it is to show you nothing. And we ended up that, yes, it is more valuable. Even the description doesn't always mean what it looks like it means, and I'm going to point that out here. In this particular script that I'm running, it's doing cloud masking on Sentinel-2 data. You'll note that the function that's being mapped over the collection ends in this clamp call. And oh my gosh, the clamp call is the thing that used the most memory. And so you think, well, maybe I don't really need to clamp, I'll just take it out and save all that memory. Not actually what happens. More or less what has happened is that everything inside this function kind of was using the same memory. This isn't true, but in a mental model, assume that all this used a bunch of shared memory and that's how much shared memory it used. We needed to assign it to something. And so it turns out that we end up assigning it to the last function here. And so all of this used 221 megabytes. If you put divide on the end, then suddenly it would all be in divide. Or if you took clamp off, it would suddenly be in divide. So it's not always true that this actual algorithm used that much memory, but sometimes it is. So, yay for ambiguity.
The first column is seconds.
The first column is Google Compute Units, which is a weird, goofy thing, but you can assume it's something like CPU seconds. It's normalized for different architectures. We can run on different architectures at the same time, yada, yada. Yeah, this script took 30 seconds to finish, and roughly.
We promise it means something.
Sure. I don't need it.
But is it, to understand it correctly, so it's what it gets sent to Earth Engine, it's literally, let's say, this tree of functions which you see, and probably with several branches. So what we see here is actually the leaves of that graph.
And not just leaves, there's nodes in the middle as well.
There are nodes in the middle as well. Okay, so it's but it's not possible, let's say, looking on just on right side to actually see this tree or which part of the tree.
And
so
it's again, it's somewhat misleading. If you use the same sub computation twice or 3 or 4 or 5 times, they all get lumped into the same thing, and they're not something we can separate out, right? If you did image.selectCloud.divide by 3000.clamp,
it gets reused,
and it gets reused, right? Before it even gets to the server, those are all lumped together into one subfunction, and the subfunction runs, and it doesn't have any way to know you're using it 5 times. It's just one big blob. This is, when I ran this, what I got back was 6 map tiles, and there were 2 API calls. So one of those calls was a get map ID to be able to put the map on the screen. I don't know what the other one was. There might be a get info in here. It might also be lying, and there was only one map ID call that ended up looking like 2 calls for us. That is, again, not necessarily useful information, but also not so unuseful that we didn't include it. So it's a mixed bag. Hopefully you'll be able to find, when you have a problem, maybe this will help you narrow it down a little bit, or it might just confuse you more. But we're hoping it'll help you narrow it down. It has come in handy in a couple places. If you're doing a big reduced neighborhood, or I detected that, a user's problem was that he's using a big reduced neighborhood with this giant kernel, and oh look, it's using 3 gigabytes of RAM. Clip has a memory counting problem, and so one user was running out of memory. Clip was the plausible suspect, and in fact we took out all the clips, and sure enough the script ran. So half the time it's on target. The other half of the time it's confusing, but someone might be able to work something out of it. So use with caution, okay? And turn it off when you're done. Otherwise, you'll be sad.
So would you recommend, say, like just taking apart that the cloud masking function and just running it line by line to see like where the memory is maxing out?
No. If you don't have a problem, I don't recommend doing this at all. If you have a problem, just run it and see what it says. And hopefully the offender is at the top. And if it's not, doing a lot more deep investigation by dissecting it, I think you're probably not, if it didn't come up in the large, I don't think it'll come up in the small either.
But certainly you could simplify your script to try to narrow down the correct attribution of the problem, if your script makes sense to simplify that way and still demonstrate the problem.
Yeah. So it's a mixed bag, as I said. Okay, any more questions there? Sufficiently confusing that there's no questions?
No, if I run the same code now and then next week I run the same code, it ought to give me the same result, right?
Within some margin, yeah.
Okay.
You may end up on different machines. It might get distributed to slightly more machines, slightly less machines. So there's some error margin that could happen there. But yeah, roughly the same answer.
Quick question on, sorry, I fear I missed something on, when you turn on enable performance profiling, you said turn off something about caching.
No, it turns off caching.
Oh, it does
Caching
itself,
goes away.
okay.
Yeah.
What is plumbing?
Other?
Yeah.
Yeah.
So is there any way to break that down?
Basically, if there was a way to break it down that would make sense to you, we would have done it. Plumbing is for the most part a category of, we are rearranging your data to put it into the next step, and that's why plumbing gets memory attributed to it. But if you see if that's at the top of the list, let us know, because it means we should probably do something better.
Yeah.
No, you were saying that if you have a function, it's going to kind of map all the effort to the last.
Now, often a bunch of things get lumped into the last thing, and whether that's in a function or not in a function, kind of happens both. So
if that's happening, the only way is to kind of try to split it out more if you really want to diagnose it, or.
If I saw this, I would give up right there. I wouldn't try any more than this, because I will attempt to explain what's really happening and it won't make any sense, but go with it. Most of the time we use on-the-fly pixel functions. The output from select goes directly into the input of less than or equal to, which goes directly into the input of update mask, which changes down further. Nowhere along the way was more than one number in memory at any point in time until some point. And at some point we said, oh, we have to stick all this into a big giant piece of memory because it's more efficient to compute it once and keep it than it is to compute it several times. And so that's called a pixel store. So we shove all the pixels into a pixel store, and that's really where all your memory went. And you really don't get any options about, did I put it in a pixel store or not put it in a pixel store? That's just something the server decided for you. And if it needed to go into it, you're really not going to get away from it. So, if I saw this and I'm like, well, maybe clamp is really the offender here, and I took the clamp off, and then suddenly all that jumps into divide, I'm like, okay, I see what's going on. There's no way to make that better. Move on. If I took off clamp and suddenly my memory usage drops by 2 gigabytes, oh, well, clamp actually was the offender here. I don't need to, that's it. It's really binary. It's one or the other. Yeah, highly dissatisfying, right? But it'll right. Half the time it's going to be exactly what you want.
I have a code that it seems to still be profiling even though the code has failed. Is it giving me a good result?
It gave you as much of a result as it could.
When you say still profiling,
Well, so I'm getting error messages in my console because usually I have to run it 3 times and cache it,
Right.
cache different chunks of it, but it's still calculating profiles.
Because it's still running.
It's for all the tiles. Each tile is going to time out independently.
As long as you're getting responses, the profiler will give you more information. Yeah.
But these numbers now, even though
Yeah, right. You got errors, so the profiler is giving you information for as much of the computation has happened before you hit the error.
I see. Okay, so it's not the total, it's just.
Okay, on to more dissatisfying things. So
This ladybug.
basically, it's not a ladybug, it's a beetle, man,
Beetle, yeah.
and it's yellow. All right, so hopefully by now you've encountered all the stuff I'm about to tell you because you have written a script in Earth Engine. And really, it's kind of hard to write a script without hitting at least one bug of some variety. But basically, there's 3 kinds of bugs or 3 kinds of errors in the system. There's things like syntax errors. These are things that happen entirely on the client. The editor actually tells you about them because it tries to execute the JavaScript and it can't. And it tells you about it with a red X. And so what's going on here is I've got a straight quote. It says, you're trying to start a string, you didn't close it. So those are things you have to fix before you can actually even run the script. So they're the least interesting because you have to fix them. There's only one way to fix it. You go fix your syntax error. The second one is client errors, and these are basically errors you made. In this particular case, it's telling me that something was not defined and it was on line 3. And so line 3 has 2 bands. This is a thing that doesn't exist. The person programming this made an actual programming error. This also happens entirely in the client, but the editor couldn't detect that. It didn't know whether that was a real variable or not. So it had to actually run the code, and in running the code, it failed. And it said, oh, because I'm in the middle of running some JavaScript, I know what line that failed on. I can tell you what line that is, and you can go fix that. So these are almost exclusively programmer error, okay? Also not so interesting, right? There's some techniques for finding these, but again, you're just gonna have to, there's no way around it, you gotta fix it. The last one is server errors. And usually these are basically our problem. It's using the pieces in an incorrect fashion and or something's wrong with the data or things that are not detectable until we're actually have some images and pixels in hand and go, hey, this doesn't match, and all we can do is throw an error. And these almost always have weird looking error messages because we're way down in the guts of the server when this happens, and we don't really have a lot of context. We certainly have no idea what line of JavaScript you were running on, or even if you were running JavaScript. Maybe you're running Python or Go or C++. But we return as much context as we can from the area, and hopefully it's got some information in it that will tell you something. And so in this case, what's going on is my map function had an error, so I was in the middle of a map function. And this is the thing that had the error. So this is the image ID that I was mapping over when the error occurred. And the error is you are selecting for red, and there isn't a red. And so that's kind of all we can tell you. Quite often, these are very unfulfilling error messages, and we apologize for that. If you get one and you just have no idea what's going on, send feedback and say, I don't understand this error message. And we get a couple of those, and it's like, okay, maybe we can turn that error message over and fix it. So in the process of debugging, I'm going to go through each of those categories in a minute here, but in the process of debugging, you have some tools. I put a nice butterfly on this slide so that there'd be something satisfying on it, because these are not the best tools in the world, right? We're back in the 80s or 70s of writing code, because your main tool is print. But when I'm debugging your code, I go in and I print stuff, right? Print everything I can, stick it on a map. If I can see your training data and I can see your image and I see they don't overlap at all, that's now easy to diagnose, right? It isn't an actual programming error, it's a data error. And quite often, that is the problem, is that it's a data error. So printing stuff, sticking it on the map, inspecting it, seeing what's going on. Inspect your map, inspect your image and see that, yeah, your problem is you have 742 bands. I see why you're failing. And inspector is the sort of the best way to get at that. As you're aware, these don't work in mapped functions, right? You can't map a print, you can't map an add layer. And so I'll show you in a minute some techniques you can use to essentially get around that to at least help you try to debug these problems. But the getting around that is often other functions that are on collection. So here's an example where I have a function that I'm mapping over a collection, and I get a really bad error message. And what has happened is way down in the add function, I've got two things. There's a left side and a right side that I'm adding together. And the left side wasn't provided somehow. It says you gotta have a left-hand side here. Perhaps it could be a better error message, but at least it's told me that the problem is with this feature, this is its ID, and somewhere in here, add, right? So there's my add, something's going on. Having debugged hundreds of these, what I know is that what has happened is that the left side of your argument here is null. So mean somehow got to be null in the process, and that got sent to the add function, and adds got null and 3, and it doesn't know what to do with that. But if you don't know that and you're trying to debug it, one thing you can do is to take your collection and filter down to the actual offending feature. And I noticed last time I presented this, I almost got it right. But filter down to one feature. So you got a collection of one, nothing in it but one feature, and see if your problem is actually that feature, or is it some other compounded problem that's going on here. So if you filter down to one thing and map over it again and you get the same answer, and you should. If you don't, now weird things happen. If you get the same answer, now you need to get that feature out and do something with it. And so what you might do is something like this. Take the collection, filter down to the one feature, and take first. And now you've got just a feature. It's no longer a collection, it's just one feature. And you can run your compute function on that feature directly. And now you're no longer in map land. Now you can print, you can map out layer, you can use all those things that you would otherwise not be able to use. Stick first on the map, print it out, maybe see what its parameters are. In the process of doing this, you might see that in fact that feature has a mean thing, a mean property, and the mean property is null. And so, okay, how did mean come to be null in the process of doing that? And work your way back up the stack. So again, when you ask for help and I'm debugging your script, this is what I do. So you can skip that and do it yourself. Back over to here. So the tools to help you do that, first you just saw, you can also limit your collection. So if you run out of memory or you run out of computation timeout or something like that, pull your collection back. So if you're doing an aggregation, a map over 1,000 images and it fails, pull it down to 100. Does that work? Okay, well if that works, bring it up to 500. Oh, okay, does that work? Oh, yeah. Maybe somewhere between 700 and 800, it doesn't work. And either there's a bad image at 740, or that's about where you hit the memory limit. And if it's memory limit or timeout, at least you can say, at least you can help us get to the point of saying, well, this works with 700 images, but it didn't work with 710. Now that's a limitation my guys can actually go work on and say, oh, well, we can fix that. But if we have to try to do that figuring out on top of figuring out what your script does is a lot harder and much less likely that we'll be able to quickly get to a solution. So the more you can limit down to the problem where this doesn't work, but that does, the easier it is to get help, and the faster it is that you'll either get a fix or a workaround. So one more. This is a function that we put in specifically for me because I like it. Every object in the system has a function on it called aside, which means go do this other thing as if nothing had happened. So what it does is it just returns the thing it's working on. So collection.aside just returns the collection, but it also runs the function you give it. And so in this case, it's almost exclusively used with print or add layer. You can, in something like this, you could do collection.aside print.filter.aside print.map.aside print, and just inline those things. The client library is built for chaining methods together. And so rather than rip that code syntax apart, rip it into multiple variables and try to print each variable, which is error prone, you can just drop this additional function in anywhere and print whatever's going on and not break the chaining flow.
But I can't do that in the function though.
If you're not using it as a mapped function, you can.
Okay. But you just, so if I said, aside.print collection, and then it filters it, and then I do it again, aside.print collection, I can't then have my aside.print in the mapped function.
Correct. Because that's printing and it won't help. Yep. Okay. So a pretty motley toolbox. Oops, sorry about that. A pretty motley toolbox to use, but it worked for 20 years of early computer science. So no. All right. So common errors. You'll probably recognize these, and I'll hopefully be able to help you at least understand what you're seeing. If not, get you a solution. Any questions yet?
I guess so. Actually, I'll hold off. And you might be able to.
Okay. So, 4 different kinds of errors. We'll talk about them each. So, an actual piece of code from an actual user. You know who you are. This innocuous looking line is full of problems. So the first thing is that it didn't do anything. Had it actually worked, it wouldn't have done anything because set doesn't actually modify anything. It returns a new image. If you didn't capture it, it's gone. So you do your thing, you set your value, and you go, where's my value? Well, you threw it away because you didn't capture it. So you've got to do some kind of result capture, stick it in a variable to be able to use. So barring that, a common problem, if you've written any code at all, you probably had to deal with this, is that some functions lose their type. So first doesn't know what it's returning. So it just returns a collection. It's not an image collection, it's not a feature collection, it's just a collection. And so there's no date function on that collection, or element. It's not even a collection, it's an element. Elements don't have date, images have date. And so you will almost certainly, if you're expecting an image here, you'll have to cast this to an image. You have to stick an EE image call around it. All right, so if that works, so now we are capturing our value, we are getting the date off of an actual image. This doesn't work. This is a JavaScript function. It runs on the client side, and it's taking a computed object, which is a crazy structure element in its crazy dictionary in JavaScript, and it's adding some big number to it. And so what actually happens is you get this crazy date element with a number just stuck on the end of it. Certainly not what you wanted, probably. And so you'd actually need to call .add here for this to work. This is someone trying to add a day to the date. So all of these are what we call early errors. They're things that happen in the browser. The server was never involved. You can you'll almost certainly get line number reports on all these because they are either JavaScript errors or so JavaScript error. The result capture you won't ever get a message on because it wasn't invalid. You did a thing and just threw the result away, and so we never even did the thing for you. So I don't know if that's an early error or a never error, but it happens a lot. So just be aware. Oh, look, somebody added a slide for me. Thanks, guys. Like you must have done that while I was talking last time. All right, just as a reminder, so because we're about to talk about it in depth, there is client-side stuff and there's server-side stuff. All the JavaScript runs in your web browser. The server never sees it. It doesn't know that you're running JavaScript. It builds a computational description that looks like this crazy thing here and ships those off to the server. So those things go off to our big black box server. The server does its thing and then ships your result back. So bear in mind, stuff happens on the client, stuff happens on the server. They are not that related. So errors that you get when you're mapping a function. All map functions have to return a value. And so when you see must return a value, that's a pretty obvious thing. You need to return something. Mapping over image collections or feature collections, you have to return something that looks like a feature, either an image or a feature. There's long, complicated reasons for this, but you can map over lists and dictionaries and return anything you want. But if you're mapping over images, then you have to return essentially an image or a feature. So if X is coming in as an image and you do X.date, it will work. That's not an image. You're going to have to return something that looks like an element.
So it's the smart thing then to map a function over a list of images?
If you want to return a bunch of dates from them, yeah, you convert the collection into list and then map over the list. Or you just return a feature with nothing in it but the date and extract them at the end. And that's usually a better option because you're probably going to do something like a big table export, and tables have to be features. You might have a reason to just get a bunch of dates out and then do something with them, but usually it's a better option to return a fake feature. As already mentioned, you can't use getInfo or print inside of mapped functions, and you get a wonderful error message when that happens, which is expression variables must have non-null names. Probably our worst error message. It's certainly at the top of the worst error messages. But what has happened is that, well, let's talk about how mapped functions work. If you've been to one of our one-on-one sessions, we've told you this, but I'm going to tell you again. When you map a function over something, what actually happens is we conjure up a fake image, or a fake whatever it is. So if you're mapping over an image collection, we conjure up a fake image. It has no metadata, it has no ID, it has no pixels, it's just a completely fake object. But we take that object and we shove it through the function that you just gave us, and we see what comes out the other end. So it returns almost always it will return a function that is applied to another function, that's applied to another function, that's applied to another function, that's applied to the fake object. In this example here, it's returning the value of whatever set returns, and set is taking a couple more arguments here. We are just a big functional composition system, and so it's functions all the way down. But what happens when we get that object out, that fake object processed and out of the function, we then say, okay, serialize yourself, turn yourself into something we can send to the server so that the server can evaluate it. And what that looks like is that we pull off the outermost function and its arguments and serialize that. And we pull off for each argument, we pull off the function that was involved in that and serialize that. And at the bottom, we eventually get down to the original input image, and that's a fake image. It doesn't have an ID, it doesn't have pixels, it has nothing on it. And we say, serialize yourself. And he goes, I can't serialize myself, I don't have a name. And so expression variables must have non-null names. Makes perfect sense now, doesn't it? It could be a better error message. This isn't the only place this occurs. There's other places that it occurs, so that's why it doesn't say you've printed a fake image. Yeah, so you know what the message means now, and when you encounter it, it means basically use to get info.
How is it different than the what you were just saying about the left parameter needs to be? What was it? The left. I get this error all the time. Left needs to. Yeah, parameter left is required, which essentially means that somehow left got turned into null.
Null is different than our fake image.
Okay.
So our fake image isn't null. It's actually a special thing, not called fake image, but could just as easily have been called fake image. Okay. And so you get down to fake image and it goes, I don't know what I am. Whereas in the null case, that a reduced region actually returned null, and then you pulled it out and tried to use it. All right, you with me so far? It gets harder here. JavaScript branching. So I told you that we take this object and we shove it through the function and we see what comes out the other end. If your function has an if in it and we run one object through your function, we probably only ever went through one half of your if. The other half never happened. And so there's no part of that that gets encoded up in the computational description that goes off to the server. So there are a few cases, and we'll talk about these. This will get weird, but if you're in a map function and you use an if, and I is your image or whatever you pushed in or some kind of variable, you're probably only ever doing one of these. And which one it is depends on what you're actually testing here. But the other one, the server doesn't know about it. You're never going to get two out of this because the server never saw the other half of this if. That said, there are a few cases where this actually does make a little bit of sense. And I'm going to tell you about it, and then you're going to go use it, and it's going to break, but I'm going to tell you about it anyway. If you're in the middle of a function and you need to use a for loop, like you want to recursively add this image to itself 10 times, okay? That's a silly reason to use a for loop, but there are worse reasons to use a for loop. And so you stick a for loop in there, and you say for I equals 1 to 10, and you say when I is 1, do this. And when I is not 1, do this other thing. That's actually going to get, both halves of that are going to get run because you've got a for loop that's running through that if loop or that if statement 10 times. So it is actually might get both ends, if you wrote it right, might both get both ends encoded. So that's one of the few places where it kind of makes sense that you could use an if you had to. But man, if you can avoid this at all, your life will be better. It will be less error prone and yeah, just if you can avoid fors and ifs, by all means do so.
E algorithms, if the server side if, or is that still a branching?
You can use the server side if you need to, but I have yet to see a case where it was actually needed. It's a convenience. It's someone who has a for loop and an if where they wanted to convert and didn't want to go through iterate or list.sequencer or some other mechanism to make that work. So yeah, you can use it, but everybody that does eventually gets bit by it. I'm looking at you. Yeah. So if you're trying to use a conditional, then there's a bit of a smell to the code that you might want to look at a second time.
Wait. So you're saying you really might never need to use a conditional?
Yeah. I've been programming with Earth Engine for 6 years. So I've got 20 abstracts and 4 papers, and I've never needed to use a conditional.
Okay.
You could
When I did, I
always,
was wrote a new thing, so I wouldn't have to, because
you can use it, but you can always transform script into something to change your logic into have kind of set-based operation. So if you need loop in if, frequently it means that okay, you would have to probably add some attribute and then filter using attribute to split into 2 sets.
almost always another way.
But it's sometimes it can be a kind of for the cost of understanding.
If
So
I need to do
you have
something-
to
Right.
change the way you think about your data input output, and sometimes it's hard to do, or especially when you migrate code.
If I
you
need to
might-
do something exactly 3 times, a for loop 3 times might be the best way to do it. Or I could cut and paste my code 3 times. I'd much rather use a for loop over 3 times than cut and paste my code 3 times. So
Right.
there's a bad and there's a not so bad,
Right.
but really there's another option. And it's just a matter of the threshold of pain. It's like, okay, I just want a for loop for 3. Well, you could iterate from 0 to 3 and then, whatever. So yeah, no, you almost never need an if.
I use them left and right, man. It's okay.
Also, one of the guys I responded to the most last year. Just saying, make it out what you will. Okay, so, right, so we were discussing this with Igor. He gave me a good answer. You're not supposed to be able to do this. So if you're in a mapped function and you try to do a big reduced region, you will probably fail. And the reason is that the system is scoped to just barely allow you to do that. So there's a parallelism, automatic parallelism of 25, which means your main thread and 24 other threads to do something with. And the parallel mapping thread does things in blocks of 24. So you have exactly 25 threads worth of things to use. And if you do nothing but a mapped function that does a reduced region, it will probably work. But if you do anything else, like get the size of that collection, do any sampling, do any other reduced regions, whatever, it'll fail because now that's 26 and you're using too much parallelization, and this is how we keep everybody from taking down the system. So what it boils down to is don't do this except in batch. Right? If you're trying to do a really big aggregation and you're trying to map it over a bunch of features or a bunch of images, export will let you do that just fine. Export will dole them out and keep them running, and it may take a while, but it will actually do them and it will cache them. So when you put an aggregation into a map, you're almost certainly going to get too many concurrent aggregations error. That's what's going on. Cut it out. Don't do it. Do it in batch if you have to do it that way. Okay? Good? You guys are asking way less questions, so this is gonna not go anywhere near 90 minutes.
We're storing them up.
All right, so whole category of things you shouldn't do. They involve for loops and lots of excessive get infos. There are very, very, very few reasons that you have to call get info, but there still exist a couple. One of them is that if you have a table of a bunch of image IDs and you want to make an image collection out of all of those, you have to run a for loop with a get info. You get info the table in the client then can run a for loop over the table to create each image independently. It's the only possible way to do that. By design, there's a whole security issue of you don't care. But that's one of the very few places where you will need a for loop and you will have to use get info to do it. No one does that. Fortunately, this is not a thing that people need to do frequently. Yeah, you do it, you don't count.
Maybe one example is useful is once you have collection and you want for debugging purposes, add just last, let's say, 2-5 layers. So then usually you have collection. What I typically do when you generate run some algorithm and you get image collection of each collection, which would contain many instances, but you want to get maybe a last 10 before you export video, for example. Then you convert to list 10 elements, loop for get info, add layer.
The places where you need to do that sort of thing are when there's a client side and a server side interaction together. So if you're doing export, map, or chart, or now UI, I guess you guys haven't seen UI, it's coming, or maybe you're going to class. These are all things that happen totally in the browser. And so that's a place where you're going to have to do some tomfoolery if you want to, for instance, export an image using a region that comes from another image. Well, the only way to do that is to get info, the region off the image, and shove it into the export call, because the export call doesn't know about computed objects. So you have to get info to bring it over. So again, a couple places where you still have to do this. We keep trying, every week we try to cut out one more. Hopefully you'll never have to do get info, but right now there are still places. But if you are trying to export 10,000 images using a for loop, you will see this. Your browser will hang, you will lose your script. It's a bad thing. So really, don't use for loops, right? If you really, really have to, just don't use for loops. Right? Just cut it out. Right? Don't do that. There are a couple places in the system where we intentionally make your life difficult because you are about to do a thing that's going to spin up 1,000 CPUs. There are places where we'll let you do it, and reduce region with max pixels is one of those places. And we call this the blade guard. You can actually remove the blade guard and stick your fingers on the blade if you've ever used a table saw. But we make sure that you know what you're doing, or we at least expect that you know what you're doing. Don't do this, right? So this is removing the blade guard and asking for 92 petabytes of data. Don't do that. Don't do that. You know that's not going to work, right?
I'm going to do it.
Yeah, you have done it. Right. So when you have to remove the blade guard, when you have to fill in one of those fields because it says, hey, you've hit a limit, that limit's there for a reason. It's to make you think about what you're about to do. And if you blindly paste in a number like 92 petabytes, you can do things like take down our entire cluster. That generally doesn't hurt anybody but you, because you'll get banned, right? You'll turn off your account and say, don't do that anymore. But it's, someone gets paged in the middle of the night, it's all just a bad thing. So make sure you have some real feel for what's going on in these cases. Like 180 to the 9th pixels, that's fine. 180 to 12 pixels, okay. 180 to the 15th pixels, no. 180 to the 18th pixels, no, it isn't going to work. Don't do that. 9 to the 21st, right? Yeah, no, don't do that. And these all work the same, right? All the max pixels, there aren't that many, but all these max pixels work the same way and are basically the same guard that you're telling us to ignore. Just make sure you know why you're ignoring it. Yeah, so one more. I see this a lot where people take their list, they convert it into they take their collection, convert it into a list, and then just map over the list. And there's a few reasons why you might have to do that, but when we're working on collections, we can be smart. We can page in pieces. We can do streaming. There's all kinds of optimizations we have on collections to make them fast and efficient, because that's the thing everybody uses. When you say, turn that into a list, we go, really? Okay. So we have to actually stick 1,000 items into a list right there, and then pass that off to the next function. And images take a certain amount of memory just for all the metadata and whatnot, and 10,000 of them take a whole bunch of data, a whole bunch of space. And so now, instead of this little bitty container that we can optimize and pass around, you're passing around 400 megabytes of data from function to function. So when you do this, and there are cases where you might need to do it, but when you do it, you're going to very quickly run out of memory because you've just blown away all optimizations that we have. So don't do it unless you got a good reason. Getting the last 10 elements out of a collection, totally good reason to do it. Getting the last 10,000 elements out of a collection, not so good. So, question?
Yeah, I don't know if that's a viable question, but why exactly do we always have to convert the collection to a list when we want to get a specific element of, for example, the second element? So you have to do list and then get the second element. Why is that exactly?
Laziness on our part. And part of that is actually naming laziness, right? Get is a thing that already exists. So you can't do collection.get_to because that means something else. And so we could invent a new one like get at or get index or some other thing there. But it would be the exact same code as converting it to a list. It's just there's an extra get on the end. So if you complain about it enough, we'll fix it. But nobody's complained about it enough for us to make the sugar to make it better.
It's not so bad. I just wanted to.
That's exactly what we said. Yeah, it's not so bad. All right, I'll just do it. Yeah, and so it's another function that looks like get is a big mental cognitive load that we have tried to avoid. It doesn't sound like much, but what do you call that? Right? What are you going to remember? So that's entirely why. Any questions yet? Really short. You guys are going to get extra coffee or something. Okay, scaling issues. We have a lot of these. These are all related to how much you can do with us at the same time. You will almost certainly get a user memory limit exceeded error soon if you haven't already, but you might have. And what I'm going to tell you is how we do what we do so that you know what this means, so that maybe there's a workaround that you can come up with. Most of the time, user memory limit is because you're working with too many tiles. So what happens is we are a tile-based processing system. Any one node in our system is about a 2 gigabyte node. Any machine is about a 2 gigabyte machine. And so tile is a megabyte.
Wait, sorry, I want to write these down. Can you say that again?
A tile is a megabyte. The machine holds 2 gigabyte. That means you can have 2,000 of these tiles in memory at once. 2001 blows up. These are all rough numbers, but go with me. If you have a 10-band image and you need all 10 bands in memory because you're doing, for instance, cloud masking, that means the most you can have is 200 images, right? 2,000 tiles divided by 10 bands, that means 200 images. If you're trying to do a yearly or a day of year processing, which is where you need 365 images and you need 10 bands, that's 3,650 tiles, and that won't fit. And that's just a fundamental scaling limit of the system right now because we're on these 2 gig machines. Again, we try to put in optimizations and streaming and ways to not need all those in one place at one time, but it's not too difficult to craft a query where you bypass whatever optimizations we've got and you really just have to put 3,600 in tiles in memory at the same time, and it's going to fail. When this happens, we put in a safety guard, or the opposite of safety guard. Yeah, it doesn't actually hurt anything, so it's not quite a blade guard, but it's called tile scale. And what you're saying is, I accept the trade-off of time versus space. So I'm willing to wait longer for my computation, set the tile scale to a high number, and we shrink the size of the tile we're working. And so you can get more tiles in memory through this mechanism. It goes from 1 to 16, but really people only ever use two options: 1, which is the default, and 16, which is the not default. So we could make it a binary that says, you know, best effort or something like that. But it is dialable, and if we were smart, we would do this for you automatically. We would say, oh, you're trying to fit 3,600 tiles in memory. That means you need a tile scale of 4.8. But we just aren't. This is a significant query optimization to be able to get it right all the time, and the trade-off in time is significant. It could actually take 16 times longer to run your computation. And we're all about the speed. Like we all have short attention spans, so it's not a thing that we just want to automatically do. We want it to go as fast as possible. But until we get smarter, there's this knob you can turn to fix, you know, perhaps fix your memory limit problems.
Sorry, no, what's the name of that?
Tile scale.
Tile scale.
And on all the functions that take it, and there's only like maybe 2 or 3, it means the exact same thing. Just use a different size tile. There are other reasons you might get user memory limit exceeded, but this is almost certainly the most common one. You're trying to do a mean over a mapped collection or something like that. The mapping does something weird, and we're not able to use any kind of streaming optimizations, and so we just shove it all into memory and hope for the best. I'm trying to remember if there's a real common.
Reduced vectors.
Yeah, reduced vectors is just a big memory hog anyway. So we can take a second and talk about why it's a big memory hog. Reduced vectors takes a tile, it finds all the homogeneous regions in a tile, and converts them either to a finished polygon or an open polygon. It's on the edge, it's open, we don't know if it's closed or not, and so we hang on to it. And so all the finished ones go into one pile, and all the unfinished ones go in another pile, and at the end, we join up all the unfinished ones and see if we can make more closed polygons out of them. If we can't, something bad has happened. But if we can, then they all become finished polygons, and then we output the whole thing. If your polygons are crazy huge, right, if you've got every other pixel set in an image, right, and they all touch, then that's just this super crazy complex giant polygon, right? It could be a 1 billion point polygon that we're trying to generate, and that's just too big. There's just no way we're going to be able to generate a 1 billion point polygon. It'll fail at the end, right? It'll go produce all the ones for every tile, and at the end, while it's joining all these points together, it's just going to keep consuming more and more memory and more memory, and then just fail. I got nothing for you. That's your problem. I got no way to fix that because it's a 1 billion point polygon. That's what you've asked for. When you're using reduced vectors and you have those problems, the answer is modify your data, right? To turn your data into something else that'll produce some actual meaningful polygons.
How does it deal with the like mask values in the raster? So said, is that?
They essentially become holes, so it draws around them.
So if I wanted to reduce the number of polygons being drawn, I could say set those to cast it as like some constant number and overlay it with just in an effort to sort of get rid of these like excess polygons.
That might do it. They become, but they'd still be polygons within other polygons. So I don't think that's going to. I think you're still going to have the same number of vertices in the end. But there might be something there where you could make that work. I can imagine setting them to the values that surround them so that it becomes no holes, and then doing it a second time to just get the holes and then maybe difference them or something. But yeah, it would all be trickery to make that work.
So this reduced vectors things, that's definitely my issue. So, sometimes your data is like, for me, a mine site or something is just, you're dealing with a lot of polygon or, a lot of vertices on that. So just the other option is just shrinking the geographic area you're looking at any given time and then just
turn the scale up.
Or what's that?
Turn the scale up. So instead of rasterizing 30 megapixels, you can rasterize 300 megapixels.
Right, which you do in the reduced vectors. Yeah, right. But is there anything wrong with doing it just doing it in small geographic pieces
No, that's fine.
sequentially or something?
Yeah, you're just going to get tile boundaries, and if you can deal with those, that's That's a perfectly reasonable way to do it. There's a whole other function called vectorize, which does it with tile boundaries. So if you're okay with tile boundaries, vectorize will probably work where reduce to vectors doesn't. It has different.
What's it called?
Vectorize.
Vectorize, okay.
It has different scaling
There's this
issues,
thing that I can bring.
but trying both is not a crazy thing. And I have a feature that we haven't technically launched yet, which is streaming reduced to vectors. And what it does is for every tile, all the closed polygons, it actually gets rid of them. It actually sends them out, and all that's left is the edge polygons. And so it has a much larger scaling factor. In fact, if you have well-conditioned data, it could have essentially an infinitely large scaling factor, or very, very, very large. We just haven't quite launched that yet, mostly because we need to have the 10-minute conversation we just had before it makes any sense, right? If you see streaming reduced to vectors in the code, it's like, what is this? It's really hard to convey exactly why or when or what that means. And if all you're going to do is then process those streaming vectors, it doesn't matter because all that data suddenly comes back into memory for the next process. So if you're exporting, that's where it works great. If you're doing anything else with that data, it doesn't make any difference. You're still in exactly the same problem.
And one thing that's so helpful to demystify some of these error messages and all that. So I always had a little bit of concern that like a lot of my programs, the first time I run it, it's not going to run, and then when it gets things cached in memory, it will run. Yep. Is that okay? I'm not blowing out Google servers or anything.
So
okay.
This is a very common problem. We'll talk about. I think do I have timeouts? Yeah, timeouts are in a couple slides, but we're going to talk about them now. There's several timeouts built into the system so that you don't consume an infinite amount of resources. The main one is that your interactive timeout is 5 minutes. Anything you can do in 5 minutes, you can do interactively at 4.95 minutes. And then it gets chopped off. But if you are trying to do a big thing and in 4.9 minutes you get 30% of the way through, it's likely that a bunch of that got cached. Maybe not all of it. Basically, aggregations, reductions get cached, and other things don't. But maybe you're doing essentially a big reduction or a mapped feature, mapping reduced regions over a feature collection or something like that. You get 30% of the way through, it times out. You run it again, you'll get 70% of the way through, and it times out. You run it again, you get all the way through, or very nearly through, and then maybe that last time you run it and it's instantly done. And that's not a bad plan. So when something fails, depending on the error message, but generally I just try again once, and then, well, okay, I have reason to think this will probably work. I see lots of things in here that could get cached. I'll try it again. So 2 times, okay. 3 times, okay. 5 times, 50 times, no, cut it out. Because you might actually be killing a machine every time you do that, right? You run it, it actually doesn't give you a good error message, it actually gives you a bad error message because the machine kind of blew up. And so if you run it 3 or 4 times, we're tolerant to 3 or 4 machines going down. If you run it 2,500 times in a for loop, we are not tolerant to 2,500 machines going down all at once. You basically take down the whole cluster, and this happens once a month. So the only thing we can do is we catch it your 1,200 iterations into your 2,500 iterations, and we see what's going on. And the only thing we can do is turn off your account, right? Just stop your account from sending in more requests. And we hate doing that because it's a pain for you and it's a pain for us. You're like, what's happened? But that's how we just turn the knob off so it'll go away. But yeah, 3 times is perfectly reasonable. And it's not, I'm sorry you have to do that, but on the other hand, you get a lot of power in 5 minutes. And if you really needed 15, well, you really need 15. So the other option is you do it in export, right? If you can't do it in a timeout and it's not being cached, you're really the only other way to get it to happen is you run a batch job that causes it to happen. So you either materialize an image or you materialize a feature collection in batch, and then you can pick that up as a cached item and use it interactively. Or maybe it's just what you're trying to get was the thing materialized.
Now, in terms of using export to do that, I'm thinking of that as you then receive that in your Google Drive or in this new thing that you've got, and then you re-upload it again. Now you don't have to.
If it was an image, then that's a different story. And maybe we should talk a little bit about rasterize, what is it, export to asset. But if you were, so a really common thing is that I was trying to train a classifier. My classifier didn't train in 5 minutes. And so I'm stuck. There's just no way, I can't run it again and pick up in the middle of training. It's just, it takes 6 minutes to train this classifier. There's no way that you can make that happen in multiple 5-minute timeouts. What you can do is you can export a little tiny image or a feature with the confusion matrix for the classifier or anything that actually causes the classifier to get finished. And it takes 10 minutes to run in batch, but then the classifier is cached in the cache, and you can pick it up interactively and use it. So this is a pretty common technique for those kinds of aggregations that it makes sense to cache. If what you needed is an image and there's just no way to get the image to work in 5 minutes, then yeah, rasterize, export to asset is probably your only option. It has all kinds of other issues, like now you're doing data management. The whole point of Earth Engine is so you don't have to do data management. So if you're rasterizing a bunch of assets just so that you can continue, then something's wrong, and we should figure out how to fix it. But you can do that, right? If you've got a really complex image to rasterize, the really complex image that you're dependent on, and you materialize it as an asset, then you can just pick it up and use it. But there's cost to that.
But there's no way to save a trained model as an asset.
There's no way to save the guts of the trained model. All you can do is for it to go into the cache, and then you get to pick it up again. There's no text representation of that. There's no way to represent those things. So you can't export them and then bring them back in. You can, for a cart only, you can ask it to explain, and it will give you the tree. So you can say, it prints it out in R format. So you can stick it into R, or you can. We have an R interpreter, cart tree parser. So you can train something in R to build your tree and bring that in through the classifier from string, I think is what it's called. But that's the closest thing we got. The rest of them, SVM, doesn't really have a good, it has a text representation, but it's not a good one. And the rest of them, like random forest or max entry, don't have a good representation. Yep.
Maybe a stupid question. How to pick something out from the cache interactively?
If you just use it the second time, then we will automatically find it for you.
And it lives there for how long? Oh, sorry.
30 days from last use, unless somebody does something silly. And so if you're the guy that caches 4 billion objects, you will flush everything else out of the cache, and it will go away. It's a pretty big cache, but it is not impossible for one user to swamp it.
Does that mean we can't use that name a second time if we want to use? So if we had, if we, for example, gave the object the name object, and then
it's not the name; it's the it's the hash of the computational description. So you build up this, you put all these functions together with all these arguments. If you ever use the same functions with the same arguments in the same order, then it becomes the same string, and that's what we pick up the second time.
Sorry, how do we get that hash?
You don't ever see it. The system does it for you automatically. And it's entirely the function name and its arguments that matters. But this only counts for aggregations, right? So reductions. If you do a reduced region with a table over an image, reduced region of a table of an image, right? The result gets cached, right? The little dictionary that comes out of that gets cached with the encoded version of the table and the image. And so the next time you do reduced region with that same table and that same image, we'll say, oh, it already exists, and just pull it out of the cache and give it to you instead. We'll come back to a couple of these, but since we just talked about it, well, let's talk about one more first. Hang on. So this is a weirdo error. I've only seen it a couple times, but it exists, and people hit it, and I have no idea what happens when it happens. This is because you did something so large that it wouldn't fit into the cache. So a reduce regions over a 1,000,000 row table, too big to fit in the cache. A reduce reduce regions on a 700 band image doesn't take very many features before that whole thing is 500 megabytes and won't fit in the cache. So computed value is too large. That's what's going on. You're breaking the cache. And when that happens, this is what you do. So you'll almost always see it when you're doing a reduced regions. So you got this big giant collection, like maybe something that came from rasterize or vectorize. It's only got 100,000 rows in it, and so it might be okay, 100,000 polygons. But then you're putting it on an image that's got 1,000 bands. So that's 100,000 times 1,000 bands. You're getting 1 million properties into your features, and a million times doubles. That's maybe 8 million or 800 million, whatever it works out to. Maybe it's too big. What you can do instead, and this works for timeouts too, is instead of calling reduce regions on the collection, you map over the collection and call reduce region on every feature. Okay, does that make sense?
Can you repeat that?
This takes all the features in the collection and produces a table that looks like the input collection, but with all the values augmented. It's one monolithic thing. It all runs at the same time. And so if it works, it's efficient and it's fast and it's the best way to do it. But if it doesn't work, because it runs out of memory, it runs out of time, or the end result is too big, there is an alternative. And it's, again, a time-space trade-off, where you say, instead of doing it for the whole collection at once, do it for each individual feature. So for every single feature, go run a reduce region. And the nice thing about this is that every single one of those is cached. So if you make it 30% of the way through, 30% of those were cached, and then 30% more and 30% more. But more likely, what you're going to do is you're going to be exporting this, and the first one will fail because it takes too long, and the second one, as long as it keeps making progress, can actually go for 10 days before we'll kill it. This is all related to time. This is generally related to timeouts, where the first one has to finish in 7,200 seconds, period. It has to finish.
And that's because the reduce regions is trying to add a property of every band to every feature.
It's a single monolithic computation. So the whole algorithm, any single algorithm, has to finish in 2 hours in export.
So it's actually doing the same thing. It's just limited by the time.
It's almost doing the same thing. Reduce regions is more efficient because it can say, oh, I've got 3 features in this tile. I'll do them at the same time.
Right.
Whereas reduce region that's mapped has to bring that tile in 3 separate times. So it could actually be a lot slower.
Am I mistaken in thinking that if say I run reduce regions on a collection, and in the first image, there are a lot of masked values. So say the polygons I'm trying to reduce over are masked, that I'm pretty sure, I feel like I lose the whole column, or I lose what I'm reducing for. And then in the export, it's just like I just get the geometry.
You'll get nulls. So if you've got a bunch of nulls, we will not. Okay, I know what you're asking. We know what columns to put into the table based on the first feature. So if the first feature doesn't have a column for a property for every, if any of those are null, the output's going to be missing that column.
So I always need to make sure that the first image in the collection is like good.
Yep.
That has
Or just stick a fake feature at the front that has a property, a 0 value property for all the bands that you're expecting. You can do that pretty easily to force it.
Do you not recommend filtering out the nulls?
Up to you, right? So it depends on what you want. Sometimes you want the null values. If you're going into a classifier, then you can't have them because we don't do sparse training. But if you're trying to export the table, you may actually want the partial rows, and then you'll actually get a null stuck in the right place.
Yeah, it's kind of similar, but a bit different. But sometimes we use reduced regions with images that have mass, and we try to use the scale parameter to kind of speed things up. So, like for Landsat, instead of doing it scale 30, we do scale like 90 or 180 or whatever. It's sometimes not clear how it deals with the mass, because is it going back down to 30 to. So it has trouble with mass if you're using the scale above the. Does that make sense?
If you're using a scale of 90, we will use the reduced resolution pyramid closest to 90. And so what that would mean in this case is 60. So it'll use 60 meter pixels, and then it will nearest neighbor interpolate those up to 90 meters. The mask that it uses is the 60 meter mask and the interpolated version of the 60 meter mask. So
Yeah, so sometimes the masks, when the pyramids of the mask can be problematic.
like on the QA bands, certainly, that'll, they're discrete values, so the mask isn't linearly interpretable. It's got to be sampled. If you can point to a specific example and say, hey, what's going on here? I can answer better. In the general, it's self-consistent. It just may not be the self-consistent model you're expecting. So,
and then the other question, which I think you kind of answered, is that if you're going to use scale parameters, best to use multiples, 1, 2, 4, 8, because that's the default pyramid scheme.
Best is a tricky term there.
Fastest, so you don't have to do like 30, 60, 120.
The interpolation doesn't. The only thing that you'll care about is how did I get my 247 meter pixel, and what that means is that it was mean averaged up to some point, and then nearest neighbor averaged that last little bit. And maybe that's not what you want. Like maybe mean averaging is not what you want, or maybe there's, if you've got weird numbers, you can sometimes end up with some reprojection noise in the result.
But it's not a slow step.
It's not, no. That was sort of the first thing we figured out with Earth Engine, is that reprojection is like the least expensive thing we do. And so we were able to just say, okay, we'll do everything on the fly. It takes longer to ping and code the output than it does to reproject the inputs. So. Okay, so we talked a little bit about timeouts. We talked about memory limit exceeded, too many aggregations I talked about earlier. If you get that one, the answer is restructure your code. You're doing something wrong, or use an export. So if you need 60 aggregations at the same time, export's the only place it's going to happen. But if you need to do it interactively, then it's going to end up in some kind of restructuring of your code.
So I've gotten the too many aggregations code, and if I run it twice, it works.
It's because some of them will end up cached and some of them won't.
And so that's an okay thing to have. It's not.
I
mean, the code is messy.
What you care about is that you got a result. And so for you specifically, where you're not building a website, you're not trying to do a quality service level agreement with your users or anything like that, yeah, it's perfectly acceptable for you. There are reasons when that's not acceptable. So.
Well, I have reasons too, because I'd like to do more, and I can't. But when is that ever going to be different?
It gets better.
It does.
Think about how bad it was 2 years ago.
Oh my God, no! I almost used part of my pop-up talk to explain how it's so much better.
So the last error that we get and is really bad is the internal server error, and this literally means we did something bad. You broke the internals. So bad that we actually don't have a good error message for you. If you ever get this, you should always click on the feedback button that it puts up and say, I got an internal server error. You don't have to say anything else. You can just type in ISE, right? Just anything so that the feedback comes, because we can see what happened and then fix it. And it turns out that feedback is the best way to talk to our engineers and get them to do something, because they'll jump on feedback. But feature requests, not so much. So always click on that, and just, you should never see an internal server error. If you did, it's our fault, and scold us. Fix this.
So this is the first time I think I've seen an internal server error, and I've only been getting them since I've been running it with enabled performance profiling on.
Yeah, so that's an important one for Kevin. He definitely wants to see those. So click that button.
All right.
ISEs because of profiling.
Well, I don't know if it's because of profiling. Could it have
I'm not a efficient coder. That's pretty clear.
You should never see it. So,
Well, but this is the thing, is it always just assume that I'm doing
You can click it and try, and it won't send it.
You may have just done a bad job of telling you about the fact that you hit a limit. Okay.
but it's always we did a bad job. So let us know what's up, and we'll fix it. 2 more errors really quick, just because you're going to hit them, and you should know what it means. feature has non-numeric values. This means you're trying to train with some data that has some nulls in the middle of it. Not allowed, then you want to filter out the nulls. Hopefully, it tells you what the feature was. This was an actual bug, long story, but usually it'll say, you know, feature 762 has non-numeric value. This almost always means that you had a fusion table with some holes in it, and the conversion fusion tables has trouble with that. So if there's some garbage in your fusion table, go fix your fusion table. Just delete those rows if you can. You can try to filter them out, but there was a bug recently that you would do this in interactive mode and it would work, and you do it in export and it would fail, and it's because we take the fusion table out of fusion tables in the process, and the conversion was making them not null anymore. And so the null filtering didn't stop working. We think that's fixed, but in general, this is a problem with your training data. Go make it not have garbage in it. And then we talked a little bit about timeouts already. There's a couple timeouts in the system. There's the 5-minute interactive one. There's the 2-hour setup limit in export. And then there's a 10-minute per feature limit in export as well. So as long as your process gets set up in the 7,200 seconds and continues making progress of at least one feature every 10 minutes, then you can run for days as that thing will come out. It doesn't really matter how complex your computation is. It will just keep churning away on it. I actually have a table right now running for paper. It's been running for 6 days so far. And yeah, it's a really big table. But as long as it keeps making progress, it'll finish.
I encounter an error where it tells me if I've just recently created a drive folder, for example, or location.
Did you complain about this on the list too?
I did, but then I realized that I just needed to wait.
Yeah, right. It's we're in one data center, drives in another data center. There can be a little bit of replication delay. So yeah, if you just wait a second after you create those drive folders, you should be okay. I think we're going to turn on automatic drive folder creation soon.
That's kind of scary.
It is kind of scary, so that's why we haven't done it yet. So yeah, typos will not be your friend then.
Right.
That's the downside. So okay, this is a terrible slide, but when you need help, there's some things you should do. And in doing this, you might actually fix your problem. So you should do it. My worst nightmare is, hi, here's my 4,000 line script. What's wrong? I don't know what you're doing. It's 4,000 lines. Like this is like 2 days of effort to figure out what's going on. We will try, but we may not get back to you for a while. And I'm looking at you. It's really big scripts kill us. So when you hit an error, the best thing you can do is try to reduce that problem down to the actual problem. So you're doing a whole bunch of stuff up here, but maybe that has nothing to do with this bit. Can you pull out the bit that you think is causing the error and reproduce it with a smaller piece? If you can, it makes our life so much easier because we can say, oh, that's this little thing. Or, oh, that's our problem, we can fix it. Here's a fix, right? So sometimes it's an hour to get a fix in if we can actually narrow the problem down to that. We will have to narrow the problem down to that for you to be able to fix it anyway. But in the process of narrowing it down, you might actually discover that this is a problem that you've created and not us, and then you didn't need the help, right? You can be off and running. So before I can even file a bug, this is what I have to do. I have to chop out every piece of your script that doesn't cause the problem and narrow it down to the smallest possible thing I can give it back to the engineer, and then they look at it and go, yep, I can fix that. They will not, they can't get through a 1,000-line script. There's just no way for them to narrow down the problem on that. So reduce the problem to the smallest thing you can. It works with 10, it doesn't work with 11. It works with, this polygon, but it doesn't work with that polygon.
Yeah, it's like that, and you can reduce your thing to the thing that doesn't make any scientific sense anymore,
totally.
as long as it produces the error.
Right.
And it's not silly for reasons that they've already covered.
The smallest thing you can get that reproduces the error, and a script that doesn't reproduce the error doesn't do me any good, right? I need to see an error before I can debug an error. So this works with 10, but telling me it doesn't work with 12, I have to go figure out where the 10 is in your script, and or K12, and that's usually more time. Like I do all my debugging in 5-minute chunks, so that's usually more time than I got. And so you'll go to the bottom of the pile and you'll get answered last. So send me a script that fails, and hopefully the smallest possible script that fails. Share your images and tables. I live in Zurich. If you don't live in Europe, that means that you send your message in the middle of the night for me. I get in the early morning when you're about to go to sleep, and I try to run it, and your image is not shared. And so I say, well, you got to share your image. And so 12 hours later, when you wake up, you say, oh, I share my image, but I've just gone to sleep. And so it's a whole day turnaround if I can't access your images and tables. We're trying to add a feature to automatically share these for you. We, say, do you want to share these things? And then you can just say yes. But it's hard, right? Fusion tables is a whole different thing, and integrating with them, and it's hard. So definitely try to remember to share your images and tables. Either if you can share it publicly, that's best, because I've got a whole bunch of users that actually answer each other's users' questions, which is awesome. But when that doesn't occur, or you have data that you can't share with everybody, then just share it with earthengine@google.com. That's just my team, and then we can actually diagnose the problem. And then send a link. Don't send me a screenshot of code. It doesn't work. I cannot use a screenshot of code. You laugh. One a month, easy. Sometimes 4 or 5 a month. The guys that send Python snippets, there's really no other option, but no one has ever sent me a Python snippet that actually worked. They always are bringing in something else. And so every single time it's like, okay, can I see your whole program? So I need something that works and causes the error before I can fix the error or tell you what the problem is. So every time you can, send a link. If you're a Python person, you probably are going to have to send a working piece of code. So I think that's it. Yep, that's my last slide. And we are right on time. So there you go. Any questions?
Can you talk a little bit about the intentional limitations regarding the too many aggregations error? I mean, because there are some processes that you can only run, I don't know, like 4 or 5 in parallel, right? So for example, I think like classification or something. Do you know what I'm talking about?
Yeah.
And I've read somewhere in the forum, there's always like mentioning like, okay, you can only run 4 or 5 of these and these, but is there like a list or something of processes? And also like maybe with the, in combination with the profiler now, like with the new feature you talked about in the beginning, maybe you could color code them or something, like so that I can see, okay, like these 4 processes, I can only run like this and this and this in parallel. I don't know, just a suggestion.
Yeah, it's way nowhere near that simple. You can have a dozen aggregations up here and a dozen aggregations down here, and they never interact with each other, and they won't cause a problem. But you could also have 2 aggregations in the middle, which might be inside of a mapped function, and that won't work. So it's really hard to generalize there about what you can and can't do. I'll see if we can, we'll tell Nick. Nick is our documentation guy, and so Nick might be able to write up a best practices for too many aggregations.
Okay. It's just like I had a script like doing some crop classification, and then I wasn't actually doing like too much stuff, so multiple temporary classification, but then like doing some filtering and so on, and I got this error a lot, so I was wondering, okay, why is that?
Yeah, there are multiple ways, and
yeah,
we'd have to see it to do it, and that's a great reason to ask for help.
Yeah, it would be just great to have like some list or something, if as good as it is possible.
It's tricky. Any other questions?
Just wondering, how big are people writing? How long are the scripts usually?
I don't know. I only see the scripts that people break and send me, well, Gana, what's your longest script, man? You're the crazy guy.
I usually try to split them, but
You're running in Node, so you get to cheat for a lot of stuff.
I think I'm running with the longer scripts. I migrate to Compute Engine, Then it's bunch of JavaScripts, bunch of other, but in some cases I had to run like long scripts and then run in a loop batch export. Then I migrate them to compute agent, even if it's JavaScript. Then they get wrapped into something which would run them, but that's. If I had to think, I have some 1,000 line scripts from the Earth Engine, and you copy paste functions, and then you start thinking.
If I had to guess, I'd say the mean is probably about 400, but that's a wide standard deviation on that. So, and we're trying to make script import work better. We're trying to make script import work so that you don't have to have single monolithic 1,000 functions.
1100.
Your text algorithm's like 500 lines, isn't it?
Right. That's why I guess.
Yeah.
Yes.
Oh, the print is long. No, I minified it. It's just one line.
Right, yeah, 1 line.
A quick plug for the user interface talk. We've got crazy new features coming, putting widgets on your maps. I highly recommend going to that talk because they're going to let you have a preview. And any we're dying for feedback before we release it to all 14,000 users. So I recommend going if that's something that you're even remotely interested in.
Who's giving it?
Max. Thanks for coming.
Thank you.
It's gotten bigger and bigger.
There were 7,000 AGU.
Right.
Doubled
This is
in 6
actually
months.
not crazy because this isn't.
Many of them are
This is a.
Right.
So this is like a new way of working with.
No, that was okay.
Okay, so it's not like a process thing, it's, it's just, initial parameters.
Yeah.
So,
You're using it to build a script.
so it's not like a process, okay, process it,
1 million.
so like.
The learning servers are, the limits on the learning servers don't get any bigger. So if you can't train it, I probably can't. How significant limitations.
It's not a condition of how we're going to go about really.
There are places where we have some limits we can modify or work around, but the training is actually one of them where we can. Export the feature.
It's getting there. So I have some really
Okay.